Thanks very much, Margaret. At this point, I'll introduce myself and talk a bit about my varied career, as Margaret has suggested, and then I'll give you a bit of information, tell you a bit about some of the research projects I'm involved in at present. In order not to distract myself too much, I'll turn off my camera now and then turn it back on at the end when we have questions. So my name is Dorothy Monekosso. I'm Professor of Computer Science at Leeds Beckett University in Leeds. My background is actually in engineering. My first degree was in electronic engineering, and I very much consider myself an engineer through and through, despite calling myself Professor of Computer Science. I just had this slide added at the last minute because very recently I visited these Horsley Towers. And to my surprise, when I went there, I didn't have any idea, but to my surprise, I found out and read a bit about the story and so realized that Ada Lovelace actually lived in this beautiful estate. So I thought I'll just add as a reminder to the date today. So just a bit of background for myself. As I said, I work at Leeds Beckett University, very much on the research side of things, although I do teach, but I'm actually a director of research. I'm involved in several projects, EU-funded projects just completing, and nationally funded Innovate UK, Royal Academy of Engineering projects. I'm also involved in several advisory boards and so on in the Leeds area. And one particular project which is quite interesting, the Inclusion Matters Northern Power, is led by Durham University. And the reason I say it's interesting is because it's about improving the experiences, enhancing the experiences of underrepresented groups in STEM, including computer science, engineering. And when I say underrepresented groups, it's gender, race, sexual orientation, disability, and so on. So from that perspective, I think it's a very exciting project with lots and lots of different activities going on. And the one I think is probably the most interesting is the reverse mentoring scheme, where younger researchers would be mentoring our university leaders. Also have fairly recently, so in 2020 started, I have a second hat. So the university seconds me for part of my time to a university owned company. So this is a spin-off of Leeds Beckett Company, and the company itself is not a digital or engineering related company. They specialize in providing health and well-being activities. But my role is in the digital transformation of this company. So over the last year, I've been involved in specifying, designing, and so on, their digital infrastructure and bringing them up to date with a lot of competitors in the area, and hopefully doing a bit more than that. How did it all start? I quite often say I was genetically engineered to be an engineer because I cannot remember a time in my life where I didn't want to be, I wasn't building something or trying to build something. So I'm always wanting to know how things worked. And I was forever taking things apart from as far as I can remember. So it's something that it wasn't a question of what I did at university. It was just which engineering degree. And I must admit, initially, I was quite tempted by mechanical engineering, civil engineering, but the advent of the first computers, affordable computers, changed all that, because when I got my first computer, I opened it up and decided I wanted to build mine. And that's how really it started. I've got a couple of pictures that I think were quite defining in my sort of journey. The first one obviously being TVs, going behind the TV as a toddler, wanting to know what was inside, where the voices were coming from, where the pictures were coming from, and how it all worked, and later on taking one apart. Second defining image is airplanes. And I spent in an inordinate amount of time at airports, going to airports observation terraces to watch airplanes take off and land. And that feeling has never really left me when I watch a plane or when I'm flying, the sense of what's going on in the engines and so on when it takes off. So those are kind of defining. The reason I have Air France is simply because I grew up in France. Had it been here, I'd have had the British Airways plane. In terms of education, my first degree is in electronic engineering. So I consider myself very much an engineer. Then I went into satellite engineering and then spacecraft engineering from PhD. And this happened because at the time, straight after leaving graduating, I went to work for a company that developed satellites. So my postgraduate studies were part-time, as well as working for the company. Early career, lots of satellites. Spent the first 11 years developing satellites, and those were small scale compared to the sort of large communication satellites. This was very small scale satellites, anything from 50 kilos to a few hundred kilos, compared to the ton you get in a communication satellite. My job there was onboard computers. I was onboard computer specialist, designing the primary onboard computer for these satellites. So I spent pretty much over the 11 years at the company. I designed, so developed and tested 12 satellite computers. I had a brief stint away from that because as I was studying part-time PhD, I had a brief stint working with JPL. Went off to JPL, NASA. And it was at that point I got involved in artificial intelligence, so applications of artificial intelligence in the spacecraft industry. And that was extremely exciting for me because I was effectively putting my love of engines and satellites and aircraft and cars and so on, and think about, well, how could we make them more intelligent with artificial intelligence? And this was kind of the starting point for a lot of the work I did and subsequently have done. A couple of pictures in my younger days working on the satellites. Seems like a lifetime away, and in fact, I think it is a lifetime away. I just found those pictures recently and thought it'd be interesting to have them. I thought they were lost. Now, how does this actually married it with what I do now? For most people, it would seem like a very long stretch between working on satellites, even autonomous satellites, and currently the smart homes, the rehabilitation technologies, and so on I'm working on. But as you'll see, it's probably not so different. I got interested as I was interested in robotics in space, I also got interested in robotics in the homes and intelligent homes, and thinking about, well, what could they do for human beings, all these intelligent systems? And I gradually and naturally gravitated towards the concept of the smart home, and the smart home that actually looks after people. And then beyond that is it, well, not just looking after people who are healthy, but what if your house was looking after you as you grow older, or you need extra help around the house? And that's, I found quite exciting. And suddenly I found a whole new area where I was applying the research I'd learned in the spacecraft industry to a whole different new sector. And interestingly, what many people don't realize is the exact same algorithms we developed in the space systems were actually the same we use in smart homes. if you think, for example, that one of the things I was doing in the spacecraft industry and started at JPL was um, being able for satellite being able to detect failures automatically and then reconfigure and sort of go along, carry on along without any human intervention. And if you think about a whole bunch of sensors in a home, it's the same thing. It's just using the same algorithms to sort of analyze the data coming from those sensors in the home and sort of making sense of them and sort of supporting some sort of decision making. Ultimately, what I'd like to see is robots in every home. And I had this picture, I had this thing in mind about the robot and Frank. I'm not sure how many of you have seen the film a few years back, probably 6 years ago. And the gentleman is given a robot to look after him, and they get out very quickly. They get out to all sorts of naughty things. But that's my vision of the future, having a robot companion in the home. And very much I hope I would have one. Some of the work I do nowadays is around decision support. Again, it's artificial intelligence, it's machine learning to support different applications. And it just happens that I've been looking recently at healthcare and how we can sort of support clinicians in making decisions. But also, and so this is healthcare, but also in social care, how we can use sensors and algorithms to support people living at home and support the care of people living with dementia, for example. So there's a lot of work around that. I work very closely with Leeds City Council and other sort of care organizations, looking at how we can support people. I'll talk a bit more in detail. I'll go into more detail into specific projects. When you talk about having sensors in the home, a lot of it is very simple passive sensors, and most people would accept having such sensors in the home. But typically, these sensors don't provide that much information. We need quite a lot of them around the home, placed judiciously around the home to sort of extract some information with some very clever algorithms. If we could have cameras, that would be quite useful because that gives a lot of information. But realistically and ethically, who wants cameras in the home? So another aspect of the work we do is looking to see how we can develop algorithms that will be, in a sense, embedded into the camera system, so that no information other than textual information comes out of the camera. So, for example, if you had a fall detector based on a camera, hopefully it's a lot more effective than, say, the standard fall detector based on accelerometer. And if out of that camera-based fall detector, only the text saying person on the ground came out of it, would it be more acceptable to people? If we could guarantee that no information other than a bit of text saying, oh, somebody's on the ground, would it be acceptable? So there's quite a lot of work we sort of been looking at. And as you can tell, as my career has progressed more and more, the work is interdisciplinary. So you work with different areas, and particularly sociology, psychology, ethicists, and so on, to sort of put a bit of sense into us engineers. I'll talk to you first about what is probably at the moment my key area of focus. I mean, there's quite a lot going on, but I've decided not to talk less about the work that's not health related. So a few years ago, I was chatting. I was at Bristol Robotics Lab, and I was chatting over lunch, and suddenly this guy came next to me, who happened to be a physiotherapist, and we started chatting about his project on physiotherapy, and it had nothing to do with technology, his project, but he had purchased a sensor, an accelerometer, and attached it to his patients. And he said, well, I've got all these data, I have no idea what to do with it. So I said, well, why don't you send it me to the lab, and I'll get some students working on it. And out of that initial idea came what's now the virtual physiotherapist. We have it's undergone many different several generations, but essentially what we're looking at is how can we support people post-stroke. So stroke survivors, typically they'd have some weakness in the limb, usually affecting one side. After the initial intensive period in the hospital, they're sent home with instructions to carry on with physiotherapy. Now they'll be called back. They will probably have physiotherapy in the community with a physiotherapist once a week or once every few weeks. But generally, between the sessions with the physiotherapist, they are asked to, and they're meant to be practicing daily, several times a day. So, for example, something as simple as lifting a glass, um, 50 repetitions 5 times a day. That's quite an onerous task for somebody in that condition. The other thing we found out was that in the UK, there's quite a shortage of physiotherapists, and obviously the cost of physiotherapy is quite high. I mean, there are also issues around traveling and so on, back and forth to the hospital, whether it's a patient going to the hospital or the physiotherapist going to the community to exercise in the community. So there are all sorts of issues around it. So we thought, well, why not if you had a system that could provide physiotherapy at home, um, and support basic exercises like the ones you see here. Um, if you think about it, those exercises are quite simple for an able-bodied person, but be quite difficult. And the whole idea is that if we had a system that could effectively complement the physiotherapist by playing the role of the physiotherapist. And we came up with this. The first prototype looked something like this. Many of you will probably recognize the Kinect, Microsoft Kinect. We use that as a starting point. The whole idea is that the Kinect, which is essentially a depth camera, tracks your movement, so tracks joint and limb movement, and we can with some clever algorithms we can assess progress. So every day, every week, you're looking at what your movement is and sort of assessing how well you're improving, or for that matter, not improving. And it comes with an interface, one interface for the patient at home, and another interface for the physiotherapist or any other clinician based in the hospital. The clinician enters the exercises the patient has to perform. The patient logs in and can get sees an example of what they have to do, and in front of the camera perform the action, the exercise, and the camera and all the system is monitoring them and assessing how well they're doing. Now, the whole process could be in real time, where you have the clinician and the patient actually seeing each other through their interfaces, or it could be independently. So the patient at home does all the exercises, and system processes the data and send off a summary of the work, saying giving some information about how well it was done and so on. One of the things we kind of found hard to do, probably most challenging thing, was less the actual um, um, engineering, is working with stroke survivors to develop an interface that's suitable, usable, and so on. So we've worked with quite a few stroke survivors to date, and we carry on doing this work to try and improve the interfaces. One of the things we found that obviously depending on who you're talking to, some are more interested in the sort of motivational aspect of the device, in terms of motivating the person to get on and do the exercises. and others are, and particularly say if you're talking to some of the doctors, they're also interested in the measurement system, how well it measures progress and so on, and sort of an objective measure of the progress and so on. At the end of the day, it's probably quite important. What's probably more important is the ability to motivate people to actually do the exercise, because as physiotherapists and the very clinicians will tell us, associated with stroke, there's always issues of depression and so on. And if you're depressed, you're not motivated to do your exercises. If you don't do your exercises, the outcomes are far worse in terms of gaining some recovery of limb motion. So this was the first, you can see now here, the first, the very first attempt at tracking limb motion, and a very basic interface. Just before I forget, this project was funded in part by ABBEY Translate, which is a research council program out of Leeds University, the Royal Academy of Engineering, UCLM, Spanish partners. I wanted to take the project to international partners, so I approached them partners in Madrid at UCLM. I've also been working with partners in Malaysia, who also have interest in the device. So this is one of my students actually working, sort of demonstrating. I think this was the second prototype where we sort of started looking at the interface and seeing how we could improve it. It's undergone much change since then, but that was the starting point. We also experimented of different ways, because if you have somebody who is partially paralyzed, how easy is it for them to switch on a device and so on. So we experimented with voice control and all sorts of different methods of starting for the patient to start the device running. And the one thing you realize when you're working with stroke survivors is that everybody's different. For some people, voice operation might be useful, but also many stroke survivors have speech problems. So therefore, voice operated wouldn't be a very useful way of interacting with the device. So one thing we realize is that almost like for everybody, you have to adapt the system in one way or another. And I think that's the advantage of technology, is that it's fairly easy to adapt systems and to make them very much tailored to the individual, rather than one solution fits all. We've been looking at, and this is very much work in progress, we've been looking at motivation and engagement. And in fact, the next stage in the project will be looking almost exclusively at that. How do we motivate people? So I've got together with specialists in mental health, psychologists, as well as the physiotherapists, to start looking at how we can motivate people, what motivates people. And obviously, we're still working with the stroke survivors, because ultimately they're the ones who tell us what motivates them. So there's a huge amount of work still to be done in that area. And it just shows how much, in a sense, the progress, the sort of changes in my work, whereas when I was working in the satellite industry, we built a satellite and we told the customer, there's your satellite, thank you for the money. Now it's an iterative process with the clients, in this case, the stroke survivors, and they're part of the design, and we definitely cannot do this without them. So that's a very big difference in the way I've worked from the start with the satellites to my current work. Another one of my, yet again, my researcher, with a slightly improved but still quite a basic interface. Now, I'll move on to, I think I've said enough about the virtual physiotherapist. This work is in progress. There's still a lot to be done. And in fact, I had a long meeting this afternoon with physiotherapists, and we're looking at sort of a study to progress this work. Now, the virtual physiotherapist is only one of several projects in the health field I'm kind of following. So I'll just give you here very brief, in the next few minutes, a very brief introduction to some of the other projects. One things we've been talking to a consultant neurologist in sort of Wakefield, and he sees many Parkinson's patients in his clinic every week. In fact, I think he specializes in PD. And a lot of time he was tell us that he would have his patients come in once every 6 months or so, and he'll see them on that day and try and assess their condition at that particular time. So he's only seeing them one day for maybe 10, 20, whatever minutes, half an hour, and he's trying to make it a judgment as to what their condition is based on that short time. But obviously, he has no idea what's happening between the appointments, 6 months between the appointments, and he'd like to know, because what he sees that day on the hospital may not be at all representative. It may be a particularly bad day for the patient. So he's seen a really bad condition, or it could be a good day for the patient, and he's seen a particularly good day, which would be give a completely incorrect assessment of the situation. So we started working with him to look at the ways of monitoring patients at home with sensors, anything from monitoring the tremors. But one thing which surprised me at the time was that more important than monitoring the tremors was looking at the grasp, how well they could grasp for an object, for example, a glass, and so on. So we're looking at different sensors, whether sensors on objects like a glass or a wearable, to sort of monitor, so that he can have a full view, full impression of the patient's conditions between the sessions, and not just have to rely on the particular day he meets them. Another consultant we sort of started working with at St. George's in London has a triage clinic for dementia, and he sees tens and tens of people coming in, and many of them are probably just are worried and are referred to him because they're forgetful. They feel they're becoming forgetful. And as he says, well, it could be just, the normal aging process, you become a bit more forgetful and so on. So he has to kind of perform some triage so that he doesn't end up sending everybody for more expensive and extensive diagnostic tools, such as MRI, which is the one end spectrum of his tools. So we're looking at ways in terms of gesture, how people, very similar to the gestures in Parkinson's, how he can detect essentially and assess their condition. So if we could actually develop some camera-based system to actually monitor people while they repeat certain just like simply touching with a finger, touching a ear or touching the forehead. For me, it seems quite difficult to understand, but for him, that's one of the classic tools, classic tools he uses in his diagnostic repertoire. So we're using camera-based systems, looking at camera-based systems and other sensors to see if we can sort of develop algorithms that can help him sort of do the triage, and he would see only those that meet a certain criteria and so on. So what the thing we found out is that the glove, we were developing a glove for clasp for Parkinson's. We found that it could also be used for in the diagnosis of dementia, which was quite interesting for us, because if from a point of view, engineering point of view, you can see how one development can meet different, with small adaptations can meet different applications. Now, this one, the e-record system, started off with discussions with Leeds City Council, the assisted living services. Um, their vision at the council, obviously, they pay for a lot of the care, even when the clients is are in private care, it's Leeds City Council or social care footing the bill, and for them, they need to find ways of one, reducing the care, the cost of care, but at the same time improving, enhancing the quality of the care. So, we've been looking at different ways of doing so. And one things they were telling me is that among all the care homes they dealt with, whether those were Leeds City Council care homes or private care homes, there's a huge variety in the take-up of digital. And so our first task was just going around the different care homes and trying to do an audit of what they used. And we found it's such a range. It was really unbelievable, from entirely paper-based care records to some being fairly advanced in terms of using digital. But what was even more surprising, there was that quite a sizable number in the middle. They actually had the equipment, telecare equipment. They had a computer, so on, with electronic records software, but not using it. And the staff were reluctant to use it. There are issues of time, digital literacy, and so on. And effectively, a lot of it also came down to training. Quite interestingly, care staff are not particularly well paid in general, but they were expected to find time on the day off to go and get the training to use all these tools. One of the things we were trying to do here in this particular project beyond the audit was to look at, well, what technology can we bring to speed up, in the case of electronic records, speed up in data inputs. So you're looking at a system where you can capture information in all different formats, whether it's audio, text, and combining all this information into a standard template of an e-record, electronic record. This involves a lot of natural language processing and so on, and it's quite a complex project, and I'm hoping to get our PhD students to start working on that very soon. Another project which we began was working with a rehabilitation specialist, medicine specialist, and who is working on a NHS. He's the lead in an NHS ward that specializes in acquired brain injury, and he wants to monitor activity levels in his patients. And the whole idea is, if you look for, you can correlate activity levels with recovery and recovery time and so on. This is a bit of a long shot in terms of how do we record the best way to record activity in people who are in hospital. And hopefully, and also because it's NHS based, there's always the getting ethics, quite rightly, a lot more complex than when you're working outside hospital. Like, for example, when you're working with the stroke survivors, this is outside hospital in the community, and therefore we use university ethics guidelines. So we obtain our ethics approval from the university. In a case like this one, it has to be NHS ethics, which is quite and expected, so quite sort of extensive and challenge to get through. I'm also working on commercial projects with various commercial partners funded by Innovate. So that's funding research, applied research funding from the government. I mentioned field projects here. One is with a company called Omega Systems. It's indoor tracking for people living in dementia in care homes. The infrastructure is beacons and so on, spaced around the home to enable us to sort of track people. Now, it sounds quite, for some people, this sounds quite on the edge of what's ethical. we work quite closely with relevant authorities and so on, and to sort of make sure we're not exceeding and developing solutions that would not be acceptable. The reason for this is people living with dementia may tend to wander, and they may wander at night. So there's a balance between having locked doors and leaving doors open, but being able to know where they are. Another project with a company is on a smart mattress. Um, I guess most of you would have heard about bed sores. If you lie in same position for a long time, as happens in hospitals, this particular mattress not only measures the pressure, so there are sensors embedded into the mattress. They measure the pressure points between the skin and the mattress, and in a closed loop feedback, it can shift the patient, so sort of shifting the body so that to change the pressure points continuously. And this, in a sense, alleviates sort of work on nurses who have to continuously be shifting patients. So when you have busy wards with lots of people, patients may not get shift as often as they should be, and this is a solution for helping the nurses. I think this is the last project I'll talk to you about. White fingers or Raynaud syndrome. For those of you who don't know, Raynaud syndrome is effectively when you lose sensation, nerve damage at the ends of your fingers, and this occurs quite frequently. People who operate heavy vibrating machinery, like the people who work on the motorways, drilling our motorways or the gas network and so on, do a lot of drilling with heavy drilling equipment, often end up with nerve damage in the fingers. And it's obviously quite a major issue for them. So this is looking at measuring exposure or vibration for people who use this kind of equipment. And it's all linked to the cloud so that that information is recorded, and managers can actually look and sort of minimize the amount of time people spend using these machines. And effectively, it ensures that companies follow the guidelines of the health and safety executive. So this was the last project I wanted to mention. And the question is really, what next? Apart from working on all these very exciting technologies, one thing I quite enjoy is working with the next generation of computer science and engineers. I very much love working one-to-one with people and trying getting them sort of excited about things, excited about all the possibilities. And there's no shortage of that when you're working in university. I recently, it was actually October, the idea came early in this year when I wrote a proposal to our Vice Chancellor. And later in the year, he authorized it and sort of funded it, working with a scheme to develop our undergraduates in very practical skills. So we offer projects, placements, hackathons with the commercial sector to our students, and hopefully they can get at the end of the when they graduate, they can get employment in some of the companies. If you want to find out a bit more, there's my email address at the bottom. And thanks very much for listening. You can take some questions now.
Thank you very much.
Switch back on my camera.
Thank you very much for that excellent presentation. I'm just about to stop the recording.